All right, we're going to continue with section 1.4. We'll call this 1.4b. I believe this is the second time that we've taught this section, the second part of it. So we are just going to jump right into an example. In the book, it's example 4, okay? And we are going to solve for x. Notice this little section right here. Solve equations that are quadratic in form. So they look like they're quadratics, but they look a little different. Do you remember what a quadratic is? A what? X squared plus bx plus c equals 0. So that's a quadratic. If you see something that looks like this, we call that a quadratic. Now this one's going to look a little bit different. We're going to do something that you may not have ever done before. At least the first part of it anyway. Then after that, it's old hat. Plus 11 x plus 2 minus 12 equals 0. Everybody see that? All right. Well, this looks a lot crazier. Hope you're paying attention because this is one of those lessons, Aspen. This is one of those lessons that you're really going to have to watch, especially at the beginning here, okay? Let me go back in time just a little bit, okay? I'm just going to squiggle. This is just off the page a little bit, okay? So this isn't really part of this problem. This is just to get you thinking a little bit. What if, okay? You don't even have to write this part down if you don't want to. If you want to, you can. What if you had this? What if I asked you to solve for x with that? Everybody see that? All right. So forget this thing right here. Okay, just look at this. Could you solve for this? Yeah. You could put it into the quadratic formula, but what do you think? Will this factor? Yeah. So look, what would you use? I would use, well, x and x, right? What would you use here? Plus 12? Minus 1? Yeah. That was pretty easy factoring, wasn't it? Would you agree? So if it looked like this, it would factor pretty easy. Agreed? But it doesn't look like that, though, does it? This is not just an x. This is an x. Now, this is an x plus 2. This is not just an x. This is an x plus 2. That's a lot different than this, isn't it? See, instead of this being an x, what is it? It's an x plus 2. Instead of this being an x, what is it over here? It's an x plus 2. So that's a little bit weird. Would you agree? Nope. I'll give you a hint. Okay? I wouldn't even expect you to know what to do here. All right? So I'm just going to tell you. Okay? Quit shouting things out. Okay? I'm telling you. You won't know what to do, all right, until I tell you right now. So it would be really nice. Listen to me. It would be really nice, instead of this being an x plus 2, if it was just an x. Would you agree? It'd be really nice if this was, instead of an x plus 2, it was just an x. Yeah? So what we're going to do is a thing called substitution. Okay? Sometimes they call it U substitution, the letter U, is because they use the letter U. I'm not really sure where that came from, but they do that a lot in math. So instead of calling this x plus 2 squared, I'm not going to call it x squared because that'll get confused with that x. What I'm going to do is this. I'm going to let the letter u equal x plus 2. I'll show you where we're going with this in a second. So don't freak out just yet. There's time to freak out. Not right now, okay? You guys watching? This is super important. This is not the time to talk. Guys, do you even hear what I'm saying at all? Okay. Just at least react like I'm trying to tell you to be quiet, okay? So everybody look. So what I'm going to do is I'm going to let the letter U, I could use any letter I wanted. I could have used A, B, C, D, whatever, okay? But for some reason, in math, they use the letter U for substitution, okay? So if this was like U squared plus 11U minus 12 equals 0, we would factor it just like we did this. Agreed? All right? So what we're going to do is we're going to replace that x plus 2 with a u. So what would it look like then? it would be, I just said it, it'd be what? U squared plus 11u minus 12 equals 0. So now we kind of made it easier for ourselves, didn't we? All right, so now I could factor this thing. All right, and remember, the u is just like any letter. You know, there's nothing special about it. It's just a variable. But it's a lot easier to factor this than it was the beginning of it. But guess what we're going to do once we get u by itself? We're going to take the x plus 2 and put it back in for the u again. All right? Because this really isn't the problem we're trying to solve, is it? This is the problem right here that we're trying to solve. Well, we're going to do this just to make it a little easier on us. And then we're going to take that x plus 2, put it back into the u, and then we can solve for x. Because we're trying to solve for x here. We're not solving for u necessarily, but this is kind of like our in-between step, just to make things a little bit easier for us. So let's work on it. You may not completely understand what I just said, but after we do a couple of these, I think it'll make a little bit more sense to you. All right? So let's factor this thing with a u instead of an x. Okay? We kind of factored it over here, didn't we? Okay, so I'm going to put a u here and a u here. And what did we do? This would be a plus 12 and a minus 1. Why do we use plus 12 minus 1? Because it multiplies to be negative 12 right here, and they add up to be plus 11 right here. That's regular trinomial factoring. We've done that a lot. Now let's continue, but we're going to solve for u. So I got two things multiplied together, and my answer is 0. So what do I do with those two things? I set them equal to 0. That's right. I set that equal to 0, and I set that equal to 0. Very good? All right. Now I solve for u. We can do that in our head. What's u equal to here? Negative 12. What's u equal to right here? It's equal to 1. All right. Now I don't circle it and say I'm done. I don't even take it and plug it back in. All right. What I have to do now, because we're trying to solve for x, I should have actually put it right here. Solve for x. Okay. Trying to solve for x. Well, I solve for u. How's that going to help me? Well, it helps me because remember at the beginning, I made u equal to x plus 2, just to make it a little easier for us. So instead of u equals negative 12, what am I going to write? X plus 2 equals negative 12. See what I did? I took x plus 2 and I put it in for that u. So instead of u equals negative 12, I put x plus 2 equals negative 12. Do the same thing with the other one. So what's this going to be? This is going to be x plus 2 equals 1. Again, I just took that u equals x plus 2 that I set up at the beginning, and I put it back in for the u. Now I can actually solve for x. Do you see how that u made it a lot easier to factor? Okay, because it would have been really hard to factor this stuff right here, okay, with that x plus 2 in there. But it's a lot easier just factoring it like this. Put it back in, and now I can solve for x. So what would I do with that plus 2? Subtract a 2 from both sides, so what do I get for x? Negative 14. It's negative 12 minus 2. Negative 12 minus 2 is negative 14. Everybody good? What do we get for x right here? Subtract a 2 from both sides, I get negative 1. Now I'm tempted just to circle that and say I'm done. But what did we talk about the other time? We got to check it, okay? So let's make sure that it works. We're putting it into the original one. Since I get this fancy little program, I'm just going to copy and paste it so I don't have to write it all over again. All right. It's up at the top. I wrote it down. Right there. Solve equations, quadratic in form. That's what the lesson's called. All right. Oops, let's go down to here so I can see my x's. So now, let's check. All right. We've got to make sure we check. Sometimes it works, sometimes it doesn't. So let's put it in here. Let's put a negative 14 in for x. Let's see what we get. Let's do a little bit in our head. Negative 14 plus 2 is negative 14 plus 2. No, it's plus. What is it? Negative 12, correct? And then we got to square it. Plus 11 times, put the negative 14 in for this. Negative 14 plus 2, that's negative 12 again. It's negative 14 plus 2, negative 14. Yeah, subtract, take the sign of a bigger number. Let's see if that equals 0. Well, what's negative 12 squared? 144. This is going to be a minus. What's 11 times 12? You know that? 132. Okay, and let's see, does this equal 0? Does it equal 0? Okay, well, what's 144 minus 132? Well, that would be 12, wouldn't it? Right, 44 minus 32. 12 minus 12 is 0. Does 0 equal 0? Of course it does. So is negative 14 one of our answers? Absolutely. So I can go ahead and circle it now. Okay, let's check one more time. Let's check the negative 1 and put it into this. Let's push it down. Let's put that right there. And let's just scooch that down. All right, so now let's put a negative 1 in for the x. Well, negative 1 plus 2 is 1 squared. We'll do that in a second. Plus 11. Put a negative 1 in. Remember, we're checking x equals negative 1, right? Put a negative 1 in for this. Negative 1 plus 2 is 1. And let's see if this equals 0. 1 squared is 1 plus 11 minus 12. That's 12 minus 12, which is 0. Does 0 equal 0? Of course it does. So what can we do with that negative 1? We can circle it, and then we're done. So much of this problem is stuff that you've done before. The one thing that you haven't done before is that substitution. Okay? This thing right here. We took a look at this, and we said, oh, we haven't taken an x plus 2 or anything plus anything squared, and then it right there. But look, they're both the same thing, so it'd be so much nicer if that was just one variable. It'd be so much nicer if that was just one variable. So let's make it one variable. Let's call it u. So let's replace this with a u. So I'm going to go u squared plus 11u, and then I just finish off the rest of it. And now it's super easy to factor when it's a u, work it all out, but once I get what u is equal to, I can't stop there. I got to put that substitution back in. I got to put the x plus 2 back into the u. I do it, get x, I check, I'm good to go. What do you think? Kind of weird, huh? Yeah, that substitution is kind of weird. You know, I think the first time I ever saw this, I probably was in college. First time I saw this. I think it was in calculus he did it, and I'm like, what in the world's he doing? So you got a head start on me. All right? So who knows? 40 years from now, you may be at Red Lion teaching math. Saying, all right. Why do I have that out of order? That's weird. I'll do it this way. Okay, so example 5. Let's do another one. It's another substitution. It's similar to what we just did. All right, so it's not a whole lot different. So we're solving for x. Solve for x. And here's the problem. It's x squared minus 1 in parentheses squared plus x squared minus 1 minus 12 equals 0. Let's take a look at it. What in the world? Does this look like a quadratic? Kind of. It kind of does because it's something squared, right? Plus something like a, let's use the a and the b and the c. It's a x squared, right? Or in this case, this is the thing that's being squared. And then it's bx, that's kind of our x, right? And then it's our c equals 0. So it's kind of a quadratic, isn't it? Actually, it's not kind of, it is exactly a quadratic, but it's kind of what we're used to seeing. I should say it that way, okay? So what are we going to do? Let's make this easier for ourselves. Let's not make this x squared minus 1 squared. Let's make it what? A u. So let u equal what?
X squared
minus 1. That thing right there. So I want this just to be one letter. And I'm going to use u, because that's what math people do. They use u to be x squared minus 1. Everybody good with that? Okay, so now what we're going to do is we're going to do our little substitution, just to make it a little easier for us. So I'm going to take this and make it a u. So it's u what? Squared. Plus, this is the exact same thing as this, isn't it? So I'm going to make that a what? A u. the number in front of it. What's the number in front of it? It's a 1, right? You can put a 1 there if you want to. You don't have to. Minus 12 equals 0. Now look at this. This looks way easier, doesn't it, to solve than what our original one does. All right, and it does factor. Okay, this works out really nice. Yes. So what are we going to use? Put a u here, put a u here. Yeah, positive 4, negative 3. Good. You should be able to do that pretty quick now, right? Do that factoring. You should be able to. I mean, you did it in Algebra 1. You did it in Algebra 2. We've done it in here. So that should be something you know how to do. They're both multiplied together and equal to 0. So I take them both separately and set them both equal to 0. That's old stuff. This is pre-algebra right here, this little step. It's negative 4, and u is 3. Kind of seems like we're done, but we're not, because we're not solving for u. What are we solving for? Solving for x. So what we're going to do now is replace that u with what we set it equal to. What did we set u equal to? X squared minus 1. So instead of u equals negative 4, we're going to write x squared minus 1 equals negative 4. And we're going to do that to the other one as well. Instead of u equals 3, we're going to do a substitution again, and we're going to replace u with an x squared minus 1 and set that equal to 3. That's the new part right there, okay? That's the new stuff. After that, it's just basically just solving for this. Okay? Let's keep going. Here we go. We got to get x by itself here. So first thing I'm going to do is add a 1 to both sides. So x squared equals, can we do that in our head? Add a 1. What's that? Negative 3. Let's do the same thing over here. Let's do 2 steps at the same time, okay? So I'm going to add a 1 here, I'm going to add a 1 here. So x squared equals what? 4. Everybody good so far? Yeah. Let's get x by itself. It's squared. How do we get it by itself? Square root. Good. Square root this, square root this. Okay, so x equals. Now, we just finished a section where we did the square root of negative numbers and we came up with I. Do you remember that? But on this one, it doesn't really say at the top, but when they say solve for x, they want to find all the real solutions. So we're not going to do the I stuff on this. Okay, because remember on the stuff that we did before, it said find like the complex answers or the complex solutions. I forget exactly how they said it. Okay, but they want real solutions for x. Okay, they don't want i's. They don't want complex numbers. So can you get a real number out of the square root of negative 3? Is there a number, a real number times itself that's equal to negative 3? There's not. So what do we say as far as this part of it goes? This part, there's no solution, right? But we still have another part though, don't we? So this doesn't work. So forget about that part of it. All right, let's come over here and let's see if we can do something here. So what do? Square root, square root. Don't forget the what though in front, plus or minus, right? So x equals plus or minus square root of 4, plus or minus what? 2. So basically it's 2 answers, right? X equals positive 2 and x equals negative 2. You could have kept it like, well, we haven't checked it yet, have we? We've got to make sure we check it. You could leave it like this if they both work, or you could leave it like this. Doesn't matter. You know what the book does? They put that little brace thing there, and they stick negative 2 in there. All right? Just so you know what the book does. So let's go back to our original problem. I'm going to copy it, and then I'm going to paste it down here. All right? So there's our original problem. So what I want to do is I want to check 2 answers. I want to check x equals 2, and I want to check x equals negative 2. So let's put them in here. Put a 2 in for this. 2 squared. What's 2 squared? 4 minus 1 is 3. And then we're going to square it. You can do that much in your head, can't you? Okay, and then plus. And then what's this going to be? 2 squared is 4 minus 1 is 3. And then minus 12. Let's see. Put a question mark here. I don't know just yet. Let's see if it equals 0. Okay? What's this? 3 squared is 9 plus 3 is 12. 12 minus 12 does equal 0. So 0 equals 0, so that checks. So positive 2, I'm good with. That works. Let's try negative 2 and see if that works. I'm just going to leave myself some room to get rid of that. Yes? Well, that's a good point. I was about to say that, and you're absolutely right. If I put a positive 2 in here and square it, I'm going to get the same exact thing as if I put a negative 2 in here and square it, right? So am I going to get the same thing? Yeah, I am. I'm going to get the exact same thing, all right? So I can just look at that and say both of those will work. I'm good to go. I can go on to the next one. Everybody good? You okay with that substitution thing?
Oh, yeah.
Yeah, it's not too bad. Yeah. Let's do one more. This one looks a little bit weirder, okay? And you know that's going to happen, right? Because the further on you go, they always get a little bit tougher. But it's the same idea. It's the same idea. This is example 6. And it says solve for x. So I'll write that down. Solve for x. And we get x plus, now don't flip out, but they put a square root in here. They don't even have an x squared, right? They're like, what's up with that? Well, let's watch what we're going to do. I want this to look like ax squared plus bx plus c equals 0. Would you agree?
Yeah,
all right. So I want that right there to be an x, but it's not. What is it? It's a square root of x, right? So let's do this. Forget about this part right here. Let's just look at this. I want this just to be a variable by itself, right? So what variable have we been using the last 2 examples?
U.
We've been using u. So Carter, tell me. Well, that's going to be a problem because, I mean, you could, but it's going to be awful because I would have to take this whole thing and square it. I can't just square this, this, and this. All right? There's no distributive property with squaring stuff. So I would have to FOIL. It's actually more than FOIL. I would have to do a distributive property with 3 things, and that would be really ugly. Could you do it? Yeah. I wouldn't do it. Okay? I wouldn't. Okay, I would do it a lot easier, and this little substitution makes it a lot easier. So I'm going to let u equal what? That I want that to be the u. So what am I going to let u equal to? Square root of x. Exactly right. Everybody see that?
Yeah.
Okay. So here's another thing. That kind of doesn't help me too much with this part right here. That gives me a 2u, so that's good. But I'm a little confused on this. What's this going to be? Well, now watch carefully. If u equals the square root of x, what would x be equal to? U squared. Very good. Why? Because I square this side and I square this side. Okay? Everybody see that? So look, there's kind of like 2 substitutions I'm going to do here. It's basically 1, but it kind of looks like 2. So what am I going to replace that x with? U squared. Now it's starting to look like a quadratic, isn't it? Because I got something squared. Plus 2. What am I going to replace that square root of x with? A u. Because I said u equal to the square root of x. Now it looks nice and easy, doesn't it? Everybody see that? That's the whole purpose of doing that substitution. Just to make a problem that's a little more difficult, easier, okay, easier to see, something that we're used to. We're used to factoring something like this. We're not used to factoring something like this for sure, okay? So let's go ahead and do it. This works out nice too. This factors. So I'm going to put my parentheses. Yeah, I put a u here and a u here. What number is going to be? Plus 3 and minus 1. Because when I multiply them, it's negative 3. When I add them up, it's positive 2. See, once you get it into that u form, then it's pretty simple to do. Can we do this in our head? Can I just solve for u right now? It's going to be negative 3, and u is going to be positive 1. Okay? I'm not finished, though. Okay? So I'm going to have to solve for x. So I'm going to replace u with what? Square root of x. okay? Because that's what I made u equal to. Do you agree? So instead of writing u equals negative 3, I'm going to write the square root of x equals negative 3. I'm going to do the same thing with the 1. Instead of u equals negative 1, I'm going to write the square root of x equals 1. Everybody see that? Just substitute it in here and here. So let's solve for x now. It's really not that hard. How do I get x by itself? Square it. Right, square that. And, nope, I got to square that. Well, actually, let me think. I shouldn't have done that. I'm sorry. Because, I apologize. You got to think a little bit of it. It seems like that's what you would do, right? It seems like what you do. But what is it really asking you? Check this out. It's saying the square root of x is going to equal a negative 3. Can you take the square root of a number and get a negative answer out of it? Let me think about this a second. I wrote down in my notes. Now I'm second guessing myself here. Oh, wait a minute! I got to think about it first before I go to the boss. All right, Mr. Rao, I'll go right to you. All right, settle down. So the square root of x equals negative 3. I wrote down in my notes. It says you can't take the square root of a number and get a negative answer. I don't know why I wrote that down, but
real numbers, which is what I think
yeah, we are.
No solution.
Right, but if I took the square root of 9, don't I get plus or minus 3?
Well,
and
the square root of 9 by itself is 3.
When you're solving for x.
But when it's an equation, you've got x squared equals 9. Then you've got plus or minus.
I don't know if I understand the difference between that, what you just said.
This is not an equation. You're simply simplifying.
Right. Oh, okay.
But if it's an x squared equals 9, then x equals plus or minus 3. Because that's a quadratic, and all quadratics have 2 solutions.
Okay, so right here, I can't just square both of these.
You can do that.
But then I would get a 9, but in my notes I wrote, and it's probably got it from the book, it says that there's no solution here as far as this.
When you get square root of x equals a negative number, there is no real solution.
Okay, so even though mathematically I could square both sides and get a 9 here, I can't really do that because... Okay. All right. So this part right here, you can't do. So if I take the square root of x, we have to understand that I can't get a negative answer for that, okay? So I can't use that. So it's not, well, but I still got this left, okay? I still got this. So again, when I'm solving for x, I'm not going to use the plus or minus. I only use the plus or minus if I'm simplifying this, okay? But if I'm solving for x here, I'm not going to use the plus or minus. I'm only going to use the positive version of it.
So then on example 5, would it just be positive 2?
Example 5?
Because we did plus or minus 2.
You got me on that. I don't know what the answer to that is. I gotta go back and relook at that. Okay. So, but let's continue with this. Okay. So, what would x equal right here?
1.
It's just 1. All right. But we got to do what though? Got to check it. So if x is 1, here's the original equation. I'm not going to rewrite it. It's right here. So let's put a 1 in for our original equation. 1 plus 2 times what? Square root of 1. What's the square root of 1? It's just 1 and then minus 3. Does that equal 0?
Yes.
Yep. 1 plus 2 is 3. 3 minus 3. So 0 does equal 0. It works. So what can I do? I can circle that, and that would be your answer. Okay? So, no, it's not too bad. This is the part that's the new part, is that substitution. And really, it's kind of nice because we took something that looks kind of crazy, something weird, right? And we made it into something that looks normal, every day, kind of friendly, and then we're good to go the rest of the way. All right, everybody got it? Okay. So, what did I say? Since it's the Eagles Super Bowl weekend, I'm not going to give you homework on this lesson, but I want you to finish the other one, which I don't have in front of me. What was it? Numbers 7 to 39 odds. Yeah, and I think I gave you like 2 days already, didn't I, to do that? Okay, so I already gave you 2 days to do this. Give me another day, all right, since the Eagles are going to win the Super Bowl and we'll all be happy. So this will be due on Monday. All right. Yeah, if you're finished it, I'll take it now. If you didn't, make sure you turn it in on Monday. That'll be fine. All right. Oh, we got some time. Let's do a couple of those then.
Yeah, it was like half.
Tell you what, I'm going to stop recording though, and then we'll do the homework problems.